Welcome to the Insightful Professor. Today we begin an exploration of a procedural language available with the Oracle database called PLSQL. While SQL can be considered the language of relational database, present in Oracle, DB2, SQL Server, and a host of other systems, it has limitations. So SQL is not a complete programming language. We might better consider it to be an input-output language, whereby we read from the database and write to the database. For the most part, that's the extent or the intended extent of this language of SQL. But if we need to do more, it lacks many of the features that would be present in a complete programming language. So in this video, we introduce a procedural programming language that has been available with Oracle database since version 6. This language is called PLSQL, and it allows us to work with SQL to read from the database, write to the database, and incorporates procedural elements not present in SQL. So what do we expect to cover in this video? Well, first, let me say that we're a bit ambitious in terms of listing the objectives here. This is more than we'll cover in a single video, so we'll do this in a couple of presentations. But overall, this is what we hope to achieve. We wish to explain the need for something more than SQL. That'll justify this language of PLSQL. Then we'll introduce the procedural language itself. We'll discuss the syntax, which will include such things as declaring variables or work areas, assignment of values to these variables, conditional statements for decision-making logic, loop control statements for iterative processing, error handling, how to deal with exceptions should they arise during the execution of our code, how to communicate with the database I/O operations. This would be embedding SQL within PLSQL to read from the database, write to the database, or perform some other operations, such as completing a transaction. And then we'll go so far as to talk about stored PL/SQL, how to write stored procedures and stored functions. And eventually, we'd like to talk about writing database triggers. Let's examine the structure of a simple PLSQL program. PLSQL is a language that belongs to the ALGOL family of languages. If you're familiar with ALGOL, Pascal, Modula 2, they're all related. They're in that family. PLSQL is one of the members of that family. So if you're familiar with any of those languages, you'll recognize the structure and the syntax of PLSQL. First, we note that PLSQL is a block-structured language. So an entire program would be similar to what we're showing here in our figure, that it would consist of one big block of code, but this block of code would have sub-blocks. These sub-blocks would be sections for declaration of variables, for executable instructions to perform some kind of operation. And finally, in the event that we have exception handlers or error handling routines, there's a distinct section that would be used to define that code. All programming languages have the ability to declare some kind of variables or work areas, and we identify those variables using some kind of a symbol. Such a symbol is referred to as an identifier. Now, an identifier in PLSQL can be used to give a name to a program object or unit itself. It could also be used to name things within this program object, such as variables, constants, cursors, and we'll explain what those are when we get to database I/O, subprograms, exceptions, and packages, another kind of program construct, and we'll explain that a little bit more when we get into stored PLSQL. The rules for coding an identifier indicate that an identifier begins with a letter, and an identifier may optionally be followed by additional letters, digits, and certain special characters, such as the $, the £, and the underscore. Identifiers in PLSQL are not case sensitive, quite different from programming languages such as Java, where identifiers are case sensitive. So PLSQL has case insensitive identifiers. Now these identifiers can be a maximum of 30 characters in length. Literals. A literal is effectively an injection of a value within the code, and these values are not represented by an identifier, but they just appear within a statement, such as I want to perform an operation of adding to the contents of variable ABC the number 1. The number 1 would be a literal injected within the program. So PL/SQL supports 4 types of literals. There are numeric literals. There are character literals representing a single character. And observe that the character literals are enclosed by apostrophes, or what a programmer tends to call single quotes. We could have a string of characters, a sequence of characters, treated as a unit, and such a sequence would also be enclosed within the single quotes or apostrophes. We also have a data type in PLSQL called Boolean, and the values would be true or false, and I suppose null would fall into this category as well. So the literal values for true, false, and null are as shown here. Notice we would enter true by saying TRUE. I've shown it here in uppercase, but true, false, and null are also case insensitive. So if you use one of these as a literal value, as a truth value, you could code it in uppercase, lowercase, or mixed case. Notice that these values are not enclosed by apostrophes. If we enclose them by apostrophes, they would become strings. PL/SQL supports several built-in data types. And these data types could be classified as scalar data types, indicating that a variable of such a type would hold a single value. They could be composite or structured data types. They could be LOB, large objects. They could also be reference types. Oracle database is what's referred to as an object relational database, which supports user-defined types. And these user-defined types are analogous to classes in an object-oriented language such as C++ or Java. When we instantiate objects from those types, we could have references the same way we could have references within an object-oriented programming language. So PL/SQL supports a data type that can assume a reference, almost like a pointer, to an instance of some user-defined type. Now the scalar data types are listed here: binary integer, and then you see number, char, which is fixed length, varchar2, which is variable length, date, and Boolean. This is one of the benefits to using this language of PLSQL over learning Java or C++ or COBOL or some other language and have it talk to the database. You have a different type system within the programming language than you would have within a database. But here, PLSQL and SQL effectively share some similarities with their compiler and recognize the same data types. So PLSQL recognizes a couple of additional data types as shown here: binary integer, not present directly in the database, and Boolean, also not present within the database. Composite types are effectively data structures. We can define something called a record, which might be similar to a row within a table, a structure that contains one value for several different items. We could also have what's called an index by table or an associative array. It's effectively an array structure, and we could use this within PL/SQL once we define what it consists of. This is not an exhaustive list of data types. The idea of the video is to introduce you to PLSQL to get you up and running fairly quickly. So our list here is intended to show you some of the more commonly used types, allowing you to become immediately productive in writing PLSQL code. We can think of a variable as a storage area that has been associated with a PL/SQL identifier of some particular data type. The syntax for declaring a variable is to formulate the identifier followed by the data type and optionally assign an initial value. The way the initial value is assigned is either by using the word default or by using the assignment operator, and then introducing that initial value. A semicolon is placed at the end of the line by convention to separate this line from the next line within the program. Notice that in all examples, the identifiers pass our test for what constitutes a valid identifier. Each one of these identifiers begins with a letter and consists of additional letters and, in a couple cases, the underscore. We then include the data type and the size as appropriate. Let's look at a couple of these in more detail. If you look at the declaration of the variable called available, it's declared as being of type Boolean. Additionally, there's a constraint defined that says the variable cannot be null. If we go back to part number and supplier name for just a moment, these had no such constraint, nor did either of these have a default value. So part number and supplier number were both initialized to the null value. When we declare available, we say nulls are not permitted by specifying the not null constraint. Therefore, we must assign some value, either by using the word default or by using the assignment operator. It makes no difference, but we have to follow that with an actual value. And in this case, the only values available would be true and false. The last two declarations are different ways of specifying that initial value. There's no difference between them in terms of the effect. So we could either use the assignment operator or we can use the word default, and it makes no difference in the end. Once variables have been declared in a program, we can populate these variables by using an assignment statement. The syntax to accomplish this would be to specify the name of the identifier of our variable, followed by the assignment operator, and then some expression of the appropriate data type. The statement would then be terminated with a semicolon. Given the examples here and the examples of the variables we declared on the previous slide, what we see is part number is being assigned a value of 257. In the original declaration, part number was defined as numeric. Supplier name was defined as a string, a character length of 15, and here we're supplying a string literal. Available is a Boolean, and remember it had a not null constraint associated with it, so the assignment statement here, in order to be accepted by the runtime system, would have to assign either true or false. It could not assign null. And finally, fee was also declared as numeric, and the result of evaluating the expression, 10.5 times the value currently stored within the variable named fee, will produce a numeric value that will then replace the value in fee. When a reference is made to an identifier, whether or not this is valid is determined by the scope of the identifier. By scope, we mean the region of a program unit from which the identifier can be validly referenced. When an identifier is declared in a PLSQL block, it's considered to be local to that block and global to all of the subblocks. So in this figure, we see X and Y being global. Those are declared within this larger block. But nested within the larger block is a subblock, which contains a variable called X and a variable called W. Those variables labeled here as local can be referenced only from within the inner block. Within the inner block, we also have access to the global variables. But within the outer block, we have access only to the global variables. The local variables are not visible to us. They are outside the scope of our reference. Now that we've discussed how to declare a variable and how to assign values, let's remind you about how a variable is initialized. A variable, when it's declared, could be explicitly assigned its initial value. We saw that that was done by using either the word default or the assignment operator, followed by the value to be assigned when the variable was instantiated. Variables will be initialized to null if they have not been given a default or initial assignment. A reference to an uninitialized variable does not result in a syntax or runtime error. However, you may not get the results that you intended because the value is null. One more thing to consider here is that variables and constants are initialized every time a block or a subprogram is entered. We talked about the scope of identifiers and the notion of an outer block and an inner block. Every time that inner block is entered, it's treated as though it is the first time the block has been executed. Thus, any variables, constants, work areas within that block will be initialized to whatever their default value is. What we want to emphasize here is the issue of working with the null value. This problem is not specific to PLSQL, but exists in any relational database that allows nulls. If you're not familiar with this idea of the null value, we suggest that you view the video Missing Information available on this channel. In that video, we discuss the null value and the issues that arise when nulls are present in the database. To bring everything together that we've discussed so far, here's a very simple little program. Remember that PLSQL potentially can contain 3 subblocks. Here we have a declaration block introduced by the word declare, and in this block we declare a variable called part number, which will be numeric, allowing up to 4 digits. It'll be an integer. We have an executable section introduced by the word begin, and in that section we simply assign a value to the variable part number. We conclude the entire program by using the word end. So this program does not contain an exception handling block. But an important thing to note about what appears here on the screen is this little slash that follows the word end. When we submit our code from the client to the server, we need some way of saying, that's it, that's the end of it, go ahead and compile and run it. And that's the purpose of this slash that appears following the end. Now, when we transmit this code from the client to the server will process the code and send back to us some kind of an acknowledgement or feedback. What will happen is we'll see a message such as this: PLSQL procedure successfully completed. This message is effectively an interpretation of the return code sent back from the server to the client. The process we just described effectively is summarized on this screen, and we'll walk you through it with a little animation. The PLSQL code is sent from a client to the server. So we create our PLSQL block in SQL Plus or SQL Developer, some application that allows us to write the code and transmit it to the server. That code is transmitted across the network, received by the Oracle database, and it will then be compiled and it will execute. And when it executes, some kind of return code is generated on the server. But that return code has to be sent back to the client. And as it's sent back to the client application receives it and provides some kind of interpretation of what this code means and displays it on the terminal for the user. So let's go to the database and view this in action. We're running SQL Plus as a front-end tool on an Oracle 18c database. Here's the code that we just discussed. Let's go ahead and run this by simply hitting the Enter or Return key and transmitting this to the server for execution. There's the result. In the previous example, we showed how the code was sent to the server for compilation and execution, and how we received a simple acknowledgement from the server. How are we able to actually communicate information or data that we wish to transmit from the code on the server back to the client application? An approach that's commonly used is to exploit subroutines that are part of the DBMS output package. Now note that this package is primarily used for debugging purposes, but it allows us to control the data or the information that's returned from the server to the client, which allows us to confirm execution of some particular task. So what it provides is a simple text I/O facility for terminal communication, and there are 3 routines that are part of this package. We could almost think of the package as a library of subroutines, and the 3 subroutines of interest to us in this case would be something called put line, put, and new line. Put line allows us to send a single character string from the server to the client. Put allows us to send a single character string from the server to the client. What's the difference? Put line inserts an additional end-of-line character. Put does not. If you did a series of puts, you would be constructing a single line, and it's not until an end-of-line or new line character was inserted in that stream that the data would actually be pushed back to the client. We can accomplish this by wrapping up a series of puts with a put line, or by using the 3rd subroutine here called new line. Its purpose is to insert simply the new line character into that input stream. Notice that both put and put line accept a single string parameter. In order for this to work, we have to understand a little bit more of the architecture of PLSQL on the server. DBMS output takes the string argument from put or put line and pushes it into a buffer on the server. That may be as far as it goes. In order to have the data that was placed in the buffer transmitted back to the client, we have to enable a pathway between the server and the client. This pathway is enabled by the client opening up something called server output. In SQL Plus or SQL Developer, we could use the command set server output on. That opens up that pathway so that any messages that got put into the buffer on the server will make their way back to the client and eventually to the terminal associated with that client. Within the code that we send to the server, within the PLSQL block that we send to the server, we would include calls to DBMS output. Here we have an example that says DBMS output dot put line. Invoke the put line routine of the DBMS output package. Pass to it as an argument the character string hello world. That will cause the character string hello world plus a new line character to be inserted into the buffer. And provided we had set server output on, this would then be rendered on the terminal on the client machine. Likewise, if we invoke put, the message goes into the buffer. But this message will not be forced back to the client until a new line character is also inserted into the buffer. And we can accomplish that by executing DBMS output new line. Here's an animation that demonstrates the process. On the server, we make a call to the put line routine, DBMS output.putLine, passing some message, a character string, as an argument. That message is inserted into the buffer on the server. For that message to come back to us, the client must previously have opened up that pathway by setting server output on. Assuming that they have, then the message will be transmitted across the network and received by the client. The client then can render that or display that on the terminal for the user. Let's take a look at it in action on our database. This PLSQL block contains the three instructions we just presented in our discussion. Note that this block has neither an exception handler nor a declaration section. We don't need the declaration section if we're not declaring any local variables. Here we have simply the executable code. This is the only section, by the way, that's required for a PLSQL block. Our first call to the DBMS package invokes the put line routine that inserts both the character string hello world and the new line character into the buffer. That will be sufficient provided we set server output on for the message to make its way back and be displayed on our terminal. Lines 3 and 4, when executed in the sequence shown here, will accomplish the same thing but requires two instructions. We've not yet enabled server output. When we execute this code, all we get is an acknowledgement. No data has been sent back to us. If we examine server output, we see that it's currently off. I can enable it by setting server output on. Now, the process for doing this is a little bit different with SQL Developer, but the concept is the same. It's the client that initiates the opening of the pathway. Now, with the pathway open, I can go ahead and run the command, submit the entire block to the server for execution, and in addition to the feedback, what I get is the content of the buffer being returned to us. And this aligns with that demonstration that we just gave you. In this initial video on PLSQL, we've explained why you need something more than SQL. In doing so, we introduced the language somewhat briefly, but we gave the structure of a program, discussed how variables can be declared. We also talked about the assignment statement, which goes into the executable section of a program, and this allows us to place values into a variable. We then demonstrated how to run a simple PLSQL program on the server by submitting it from the client to the server for execution. In that process, we explained how the feedback message was returned and then generated for the client. We also explained how to return additional information from PLSQL executing on the server by using the DBMS output package, using the put and put line routines. If you found this video helpful, give us a thumbs up, and furthermore, consider subscribing to the channel because we'll be continuing our investigation of PLSQL. And once again, thanks for watching.